Welcome to the Walking Clearwater podcast. Whether you are a student, a science enthusiast, or simply curious about the invisible forces shaping our world, this podcast will break down complex ideas into clear, insightful discussions. Join me as we uncover the mysteries of Maxwell's equations, the nature of wave propagation, the electromagnetic spectrum, and the real world applications of these waves from radio signals to X-rays and beyond. So tune in, stay curious, and let's journey through the field of electric and magnetic waves, unlocking the secrets that power our modern world. Welcome to the Walking Clearwater, a podcast where we illuminate the depth of physics one concept at a time. I'm VB Kataria, and in this series, we embark on exploration of electromagnetic waves, a fundamental chapter in physics that unifies electricity, magnetism, and light. Starting from the basic concepts, let's dive into it. 1. Need for displacement current. Ampere's circuital law for conduction current during charging of capacitor was found inconsistent. Therefore, Maxwell modified Ampere's circuital law by introducing displacement current. It is given by ID is equal to epsilon naught into d phi E by dt. Modified Ampere's circuital law is closed integral of b dot dl is equal to mu naught into I plus epsilon naught into d phi e by dt, where phi e is equal to electric flux. 2. Electromagnetic waves. The waves propagating in space through electric and magnetic fields varying in space and time simultaneously are called electromagnetic waves. The electromagnetic waves are produced by an accelerated or decelerated charge charge or LC circuit. The frequency of EM waves is nu is equal to 1 by 2 pi under root LC. 3. Characteristic of electromagnetic waves. One, the electromagnetic waves travel in free space with speed of light c is equal to c into 10 raised to power 8 meter per second irrespective of their wavelength. 2. Electromagnetic waves are neutral, so they are not deflected by electric and magnetic fields. 3. The electromagnetic waves show properties of reflection, refraction, interference, diffraction, and polarization. 4. In electromagnetic waves, the electric and magnetic fields are always in the same phase. 5. The ratio of magnitude of electric and magnetic field vectors in free space is constant equal to C. E by B is equal to 1 by mu naught epsilon naught is equal to C is equal to 3 into 10 raised to power 8 meter per second. 6. The speed of electromagnetic waves in material medium is given by V is equal to 1 by mu epsilon is equal to C by mu r epsilon r is equal to C by n, where n is the refractive index. 7. In an electromagnetic wave, the energy is propagated by means of electric and magnetic field vectors in direction of propagation of wave. 8. In electromagnetic wave, the average value of electric energy density and magnetic energy density are equal. 1 by 2 epsilon naught E square average is equal to B square by 2 mu naught average. 9. The electric vector of electromagnetic wave is responsible for optical effects and is also called the light vector. 10. Electromagnetic waves carry energy and momentum. E is equal to hc by lambda. P is equal to u by c is equal to mc. The other topic is transverse nature of electromagnetic waves. Sorry. The electromagnetic waves are transverse in nature. In electromagnetic waves, the electric and magnetic fields are mutually perpendicular and also perpendicular to the direction of wave propagation, such that E vector, B vector, and K vector form a right-handed set. K is propagation vector angle along the direction of propagation. 5. Electromagnetic spectrum. The electromagnetic waves have continuous wavelengths starting from short gamma rays to long radio waves. The orderly distribution of wavelength of electromagnetic waves is called electromagnetic spectrum. The complete spectrum is given in this table. Let me just show this thing. So serial number starting from 1 And there is the names, then the wavelength range in meters and frequency in hertz. So the first is gamma rays, then X rays, ultraviolet rays, visible rays, infrared, and microwaves and waves. And above gamma rays also there is one rays there which is cathode rays. And but cathode rays is not in this table. I'm very sorry for that, but it's also there. All right, and it has the, as you might have guessed, the shortest wavelengths and the most amount of frequency. So yeah, that's the table. You should remember this one table. All right. For those who are students going for any kind of exams or anything, and especially uh, this table. And there is also one more thing, which is wavelength range of visible spectrum. So visible light has continuous wavelength starting from 400 nanometer to 750 nanometer. For convenience, it is divided into seven colors, which is violet, indigo, blue, green, yellow, orange, and red. Violet has the wavelength from 400 nm to 420 nm. Indigo is from 420 to 450 nm. Blue has 450 to 500 nm. Green has 500 nm to 570 nm. Yellow has 570 to 600 nm. Orange has 600 to 650 nm. And red has 650 to 750 nm. Seventh is uses of electromagnetic spectrum. First is gamma rays. Gamma rays are highly penetrating. They can penetrate thick iron blocks due to high energy. They are used to intimate some nuclear reactions. Gamma rays are produced in nuclear reactions. In medicine, they are used to destroy cancer cells. X-rays, so second, are used in medical diagnostics to detect fracture in bones, tuberculosis of lungs, presence of stone in gallbladder and kidney. They are used in engineering to check flaws in bridges. In physics, X-rays are used to study crystal structure. Third is ultraviolet rays. They provide vitamin D. These are harmful for skin and eyes. They are used to sterilize drinking water and surgical instruments. They are used to detect invisible writing, forged documents, fingerprints in forensic lab, and preserve food items. Fourth is waves. Infrared rays. They are produced by hot bodies and molecules. These waves are used for long distance photography and for therapeutic purposes. Fifth is radio waves. Radio waves are used for broadcasting programs to distant places according to frequency range. They are divided into following groups. First is medium frequency band or medium wave, 0.3 to 3 megahertz. Second is short waves or short frequency band, 3 megahertz to 30 megahertz. Very high frequency VHF band, which is 30 megahertz to 300 megahertz. And fourth is ultra high frequency UHF band, 300 megahertz to 3000 megahertz. And sixth and the last but not the least, microwaves. They are used by special vacuum tubes known as klystrons, magnetrons, and gun diodes, GUNN. Their frequency range is 3 gigahertz to 300 gigahertz. They are used in radar systems for aircraft navigation and microwave used in homes. So yes, people, that was the chapter. I hope that you guys have understood it and enjoyed it, and stay tuned for more podcasts like this. Thank you, everyone.